principal engineer at Experience. So he has a background working at the IT companies in the Silicon Valley for many companies. And today he's going to present us the dev container, the ultimate hack to fix messy developer setup. So in this talk, we will get to know about the dev container and how does this one, the dev container make your life easier. So please welcome Mr. Mani. Yeah.
Good morning, everyone. I think someone told me that since I am the first talk today, I have to wake up everyone. For that, I have to wake up myself. Hopefully, this is interesting and you like the talk. Yeah, so we've, I think we lost. Okay, so let us start from here, right? How to manage dependencies without having to learn this dog's name is Brandy. Sounds strange, right? It's strange. So let me tell you a short story. So I was trying to set up a project, an existing project, in my local laptop once, and when I was trying to do that, I ran into dependency issues, which we all do with different programming languages, right? That time it was Python, and I was running into a Python dependency issue, and one after another, like the package that I installed was not compatible with the one that is required. And as any engineer would do, I started Googling for the error that I got. And I ended up in a Stack Overflow thread. I was looking into the answer. And while browsing through the answer, a cool meme popped up. And we don't ignore that, right? It is the law. When there is a meme, you look at it. And while looking at the meme, then I got into the world of memes. I took my mobile phone. I looked at 100 other memes before finding the perfect one to send it to our friend. It was 2 a.m. in the morning. It was important, right? And while looking at the memes, there was one meme with Brad Pitt, actor Brad Pitt in it. I mean, I love the actor, so I was curious. What is he doing right now? I started Googling what is Brad Pitt doing right now. And I ended up in a news article which spoke about this dog. This dog acted with Brad Pitt in the movie Once Upon a Time in Hollywood. And that is how I got to know that this dog's name is Brandy. Now that I know, you all know that this dog's name is Brandy. Now, where did I start? I started looking for dependency issue, and I ended up here. So it's very easy to get lost in internet, right? So this, I mean, it works on my machine is a common thing. I mean, if you look for the memes, I mean, you would find hundreds, thousands of memes about that. When you have a application setup, it should work in everyone's machine, right? Not just my machine. And as developers, we don't want to waste hours spending hours setting up our dependencies, right? And not everyone's laptop will be running the same operating system. So someone might have Mac, I might have Windows, and the application itself might be hosted in Linux. But we want our application to work anywhere, and especially as a developer, we want the setup to be easy, right? And dev container is one of the ways to resolve this dependency issue. Now, what is a dev container? Before we get in there, so dev, this is not something new. This has existed for a while, but I found that not many people are using this, which is why I want to do this talk. And I have tried to squeeze in as much information as possible within 15 minutes of my talk. And there is more. You can always look up for more information. And I have given a GitHub link where I have hosted a sample project with dev container in it. So what is a dev container? So it is a prepackaged developer setup. It runs with Docker with pre-configured tools. Tools like, before tools, you will have your operating system, which operating system you want to start with, and like whatever the tools you need. If you have Python, you would install all the pip dependencies, and if you run Ubuntu and you want to install operating system dependencies, you can do that with your Docker file. And it will be the same on any OS. You can bring up the container and get started right away. You don't have to worry about installing dependencies. Now, why dev container? So number one is reproducibility. So if it works on my machine, it will work on everyone else's machine, which is very important when we work as engineers, right? When there is a bug, we want to reproduce this, which is very important for us to like solve the bug itself. And dev container will help us there with that. And number two is security. So how is it secure? So I mean, when we install anything from outside world, there is a chance that we might give access to our host machine to somebody else. I mean, there is a chance, right, with everything. But when you run inside the container, um, then you localize that to only with the container. It will not be the whole host. In that way, it is secure. But if you mount the slash to the container and run it as root, then it is a different story. But if you run it with the best practice, I mean, I believe it is more secure than running in the host itself. And number three is documentation. No matter how many README pages we write, no matter how many Confluence pages we have, there is a possibility of having drift. The code might have evolved. We might have installed new dependencies, but the documentation may not be up to date. But when you have your dev container and dev container.json file, which I'm going to talk about in the next slides, it will be a living documentation for you. So anyone can look at that and see what the dependencies are and how you are installing. And it enables remote development also. I'll talk about more about remote development in one of my next slides. So what is inside dev container? I spoke a little bit in a previous slide also. It has pre-installed developer tools which you need to bring up your application. And so you can, in my case, I use Visual Studio Code. You can have extensions per container. You don't have to like whatever extensions you need for your Visual Studio IDE, you can specify it in your dev container.json file, and that will be localized only for that application. And it has pre-configured terminals where you bring up a container. So when you open a terminal from VS Code, it's going to open a shell within the container where you'll have access to all the files, and you can run commands as if you're in a normal terminal. And it will be a consistent environment across team, no matter whatever the operating system that they run. How to use a dev container? Step one is you need a dev container extension. So Visual Studio, as an example, so you can like go for extensions and look for dev container extension and install it. And step two is to add a dev container.json file, and that is where you will specify what your Docker file is. And once you have a dev container.json, your Visual Studio will automatically detect it and ask you if you want to reopen in a container. And once you click on that, boom, and the magic happens. You will be up and running with the dev container with all your files mounted inside the container. You'll be able to edit the files as is in a host, but it will be reflected in the host as well because it is mounted as a folder. Yeah, this is an example. So I have the demo code link here, which is in GitHub. You can look at it later if you're interested. And so we'll have a settings.json usual, which will have Visual Studio project settings. And dev container.json is the one that we have added for telling what is the Docker file and where it needs to be mounted, all those things. And how it will work is local folder will be mounted inside the container. And so this is a sample Docker file. So I have given the Docker file. So one and forwarded port is basically I have started up my application in port 8000 within the container, and forwarded port 8000 means the port will be exposed to the host in port 8000. And mount is where you mount the local folder, host folder to inside the container, and the custom extensions which you can add uh, for your Visual Studio. This will go. I mean, these extensions will be installed only for that container instance. So since this is a 15-minute talk, I couldn't do a live demo, so I've recorded it here. I'll walk you through as this goes. So I have a Fast API project, Python Fast API project. I'm just opening that. I just have the cloned folder. So all I'm doing is opening that folder. Um, so once I open, Visual Studio opens it here, and it'll prompt saying, I have found a dev container.json file. Do you want to open in a container? So once I click on that, so if the Docker image is not built yet, it will start building. Or if you have specified a Docker image that is in Docker Hub, it will pull the image. So since I have already built it, it starts up the container with the image. It has already started. So now you see all these files here, right? This is from inside the container. So now any change that I make here, that is going to reflect in the host. And so what I'm doing with this app is I'm just running a Fast API with Uvicon, and which is on port 8000. And you can see like this host port 8000 is exposed here within the ports. Now, if we open a terminal, it should open up a terminal within the container. Now let us start the app. So I am just starting my main.py. Python path is current folder, and starting main.py, which is my main file. So now application startup is complete and open in browser. Hello FOSSASIA is what we want as the application to print. That's pretty much it. So no matter, if you clone the code that is in GitHub, all you need is have Docker installed in your machine, and you can just get started as is. Like it will prompt for deopen in container, and you just open it and you get started. So this will be the same for like anyone who tries to do that. Simple, right? And so how is it like enabling remote development? Like now that we are in AI world, uh, so so we might want to build a model in powerful machines. For example, I may not have the GPUs that are required to build a model. I might go for a cloud provider who would give the GPUs. So when I have that, I want my application to code to run in a remote cloud. So if you run as a container, then you can connect to that remote machine that is running the code, and it is the same setup everywhere. So you can basically escape slow corporate VPNs, and you can connect to the cloud and start working there. And so now wrapping up. So with dev container, it's pretty much zero setup time. So once you clone the code, you can just get up and running, and it offers remote development support as well. And dev containers just work as we saw. And fronts don't let other fronts struggle with setup, right? That is pretty much I had on dev containers. Thank you so much for listening to me so far. Hope it was useful. Thank you. And I have my coordinates here if you want to connect. Thank you. Yeah.
Any question? Yeah.
So we have only 2 minutes. We can take questions here. And if there is any more questions, you can catch me around here. Yeah.
Question is around like they would only one application.
Right.
Let's say if there are multiple applications, consider an example of microservices
Mhm.
where you have like different teams are working at a different location
Right.
and different work streams, right? So
Right.
how in that case that maintenance will come into picture and how it will help?
So your question is, I mean, we might have different applications which needs to like work together,
Yeah.
right? If I bring up a container, it
Yeah.
might need another dependency like
Another
MySQL.
container.
Okay, yeah. So yeah, good question. So I mean, when I am developing something, I mean, I can put all my dependencies in a different container and bring up that container. I mean, it's called sidecar container. For example, I mean, if I want MySQL to be up and running, I can have it running as a sidecar, and you can like use that to connect when your application is developed locally. Yeah, and same is in staging, testing, or production anywhere. You can run it as a sidecar. That is one solution. I don't know if I answered your question.
Yeah, somewhat like.
Okay.
Let's say, for example, I have a API
Uh-huh.
which gives me a login.
Okay.
It authenticates myself.
Got it.
So that is running as a separate container or a
Okay.
separate service altogether.
Got it.
There is a booking service
Okay.
that takes that authentication.
Got it.
The booking team is different and the authentication team is different.
Got
In
it.
that case, how this container will come?
Oh, okay.
So that's the thing.
Got it. So assume you have a different application altogether, which is cloned separately, and you are doing development separately. So if you're working on this application, you can just bring up that container separately and connect to it. Okay. Thank you. Thank you. Yeah, sure. I'll be around. Thanks.
Thank you very much, Mani, for the great session about the dev container. Coming up next is the coming up next we have Satyajit Bulake from SUS. He is a senior software quality engineer, and he will introduce us about the accelerating continuous delivery with GitOps, a developer's guide to streamline development. In this talk, we will learn more about the GitOps to do the CI/CD streamline using Launcher and Fleet. Please welcome Satyajit.
I have given the link actually in the form, Google form. I can open it here. Can you please help me with that? Sorry. Thank you.
You memorize the code.
Yeah.
You will want to use the incognito.
Okay. Just a second.
Otherwise, everyone can see your email.
It's fine.
Okay. Okay, just a moment before setting up the slide. Anyone have to the using GitOps here in the room? Anyone using GitOps? Okay, some hands. Okay. So anyone here want to learn about the GitOps or like interested in using it? The GitOps? Okay, yeah, wow. So many people excited for this session.
I need to adjust the microphone. Is her the next speaker?
And so
Oh, Jesus, that's so nice. Hey, guys. Hey.
Especially he got a certificate. Have you?
I actually not sure if I can use it.
Yeah. Can you put the link? The link we can type in the link.
Thank you. Okay. Good morning, everyone. Sorry for the delay in the presentation. Okay. Without wasting further time, we will get into that. So, how many of you are aware about GitOps basically, and how many of you are having developer background and need to run your applications daily on different Kubernetes applications or something like that? Okay, many. Thank you. So, but I will cover for all, like starting with the what is Kubernetes basically. So Kubernetes is basically a container orchestration tool basically, which is widely available. So containers where you can deploy your applications there. Okay. So let's dive into that. First, we understand what is K3s. So before going into the K3s, basically, we will have to understand what is Kubernetes. So it is full-fledged of orchestrating your containers, basically. But you have to have a lot many system requirements for that. Like 32 gigabytes of memory is required. Some storage is required there. So what will happen? You will have resource constraint there, right? But you are already developing your application, you are already into the code, and you wanted to try that new feature or something, then you don't need to worry about the setup or something like that. So there is a tool called K3s in the market available. It is CNCF project actually. So you can directly go and you can download your K3s there. So K3s is basically a lightweight Kubernetes basically. We pronounce Kubernetes as a K8s because there are 8 letters inside that between K and S. Similarly, the half of the resources, half of the things, that is K3s basically. There is no change in the in the essence of Kubernetes basically. It is just meant to have your edge devices, your what we can say the limited resources, something like that. If you want on the go Kubernetes on your system, then it is for you. Okay. So let's dive into the what is K3s basically. I have already told that K3 is basically a compact Kubernetes solution. And then if you have limited resources or something and you want quickly, it is similar like you spin a container. It will be like in a minute or in a seconds, right? Something like that, you can spin the K3s as well. So there is a documentation for that. In my demonstration, I will rush a bit for the concept, but in the demonstration, we will see how K3s is being installed and etc. things. Okay, there are a few key features of that where you can see that it is mainly for the development purposes. Then you can use it for the edge computing or something. Because nowadays, if you see the edge computing, we require instant container creation or something like that. So where you can use the K3s in place of that. Instead of using containers, you can use a group of containers which is deployed with the multiple applications on the particular edge devices or something like that. So this is what it is. So now let's move towards the another thing. Okay, so considering the fact that you are now aware about K3s, like I know it is a bit like a big rock actually to digest or something, but what we can do here is that what if you have multiple Kubernetes on your premises, or you have multiple Kubernetes where you have to test the application, like Kubernetes on the Azure proprietary vendors like Azure, AWS or GCP or something like that. Then you have multiple Kubernetes environment. So how you access those things, how you manage those things, right? So you don't have only one or two or three Kubernetes, right, in your environment. So you have multiple things, multiple Kubernetes environment. So for that, there is a open source rancher is available there. So this rancher is basically this rancher is basically a community edition where you can orchestrate your Kubernetes over here. So you can add your multiple Kubernetes environments. You can import your existing Kubernetes there, irrespective where it is installed. It could be in the cloud, it could be in the on-premises. So this is basically the rancher is used for that. Like you can say the UI on the Kubernetes, so you can orchestrate, you can manage, you can have your RBAC, role-based access control, and few other features there, like you can manage your securities and the things, etc. Okay, so these are the few key benefits of that. What rancher can benefits with your ecosystem that you have currently with your multiple Kubernetes resources that are running basically. So as I said that you can add your logging monitoring there as well, which will be the another headache for the developers or maybe the administrator to look into that, why my application, why my Kubernetes environment is having any problem or something, or maybe a statistical information where my resources are more consumed basically. So you will require observability, or maybe you will require monitoring or something like that. Okay, so now okay, sorry, this is the morning time, I'm getting a little bit dizzy, so I'll take my coffee. Yeah, okay, it was just I was checking whether you guys are awake or not. Okay, so now we move to the main part of my presentation basically, that is GitOps. Okay, so GitOps is basically a tool, we can say that why GitOps came into the market, because nowadays every project is on the GitHub or maybe any version control system. We can say it is on premises GitHub or your on premises GitLab proprietary vendor or some etc. things. So what you can do, you can directly place your application in the GitHub, and you can link that particular thing with your Kubernetes cluster existing, and then you can have application pushing there and immediately testing it there. But there is a small problem. What problem we can discuss later. Then we can have this few of the information about how we can manage your infrastructure etc. things with the GitOps and everything. Then we have few benefits of that as well, like you can streamline your deployment processes. This is what my talk is centered to that. But mainly there is a problem with the GitOps. I would not say a problem, but I would say a limitation there. So you can't test your multiple Kubernetes resources, you can't test your single application on your multiple Kubernetes. How? You have to every time go there, and you have to switch your context with every Kubernetes running in your environment and test that application. So that is a tedious task, right? So what if I gave you a solution where this problem can be minimized? that overhead can be minimized. So we have continuous delivery feature in the rancher, and this can be separately used as well. As a fleet is open source, you can go to the github.com /fleet, you can use that as well, so there is no limitation for that. So what is continuous delivery basically? So it is basically a solution for your multiple Kubernetes resources, multiple Kubernetes, I would say, environments which you are currently running. Maybe your organization is having multiple Kubernetes, like I said, so this can be there. So I'll quickly go forward there. Maybe you can read the slides later onwards. So I will quickly cover the features of the fleet basically. So you can manage. Oh, sorry. It again pushed me to drink my coffee. Okay. Okay. So fleet will give you. So it is basically has a targeting system. So in the fleet, basically you can target. It is another solution for the GitOps basically, but with more facilities over there. So you can use your multi-cluster things. So if you have Kubernetes installed in a multiple environments like Azure, GCP, or something like that, then you can point those clusters in a single go, in a single file. Okay, that is how the fleet comes into the picture. And we have this centralized application management. Then it facilitates the synchronization across multiple clusters. So immediately you will update your GitHub code with your application. It instantly it instantly apply those changes to your respective clusters where this application is being installed. So there is a hassle-free uh, there is a hassle-free step that you can manage there. So you don't need to worry about, okay, go to the application or something. You just need to open your browser where you have this fleet installed in the rancher, and you just need to monitor where everything is installed perfectly there or not, and you can push your changes there, and you can seamlessly see the results of that. This is not the only one feature of that. There are multiple features. So you can look into the fleet website as well, which is in my last slide. So I will quickly move towards the demo. So in the live demonstration, I tried to cover up. If my talk time is not allowed me, I will post this on my YouTube, or maybe I can give a link into the slides as well, so you can take a look into that briefly. But in my demonstration, I'm using K3s, which is lightweight, because I wanted to prepare this demo for this FOSSASIA very last minute, which will the another use case for that. I can immediately spin up the K3s cluster. I install the rancher there with the hem package manager. Rancher is basically hem apps. You can use the hem apps basically, like your normal application you can install. Then afterwards, fleet is by default installed with the rancher, so you don't need to worry about that. So you can install the fleet separately as well. Oh my god, my laptop also requires coffee, but I can't fit them. Okay, so this is the link for the demo. As I promised you guys, I'll open it over here. Yes. So without wasting your further time, I'll be at this laptop, and here I have created a small bash script. I know it is not a bash script; it's just copy paste of commands. But I have, for a save timing, I have just included into that. So I'll quickly go over that. So this is the curl command you can find with the specific K3s version. This version is as similar as your Kubernetes environment. So I said that there is no big difference between the K3s and the Kubernetes. It's just a matter of your resources. It is the same essence, but you will get the immediately with the resource constraint and everything. So here I'm passing few parameters, servers and cluster init thing. So, and after that, I'm just copying the kubeconfig file. Then in order to access this rancher later onwards with my local IP address, I need to validate some certificates there, just to allow my browser and not restricting it in between my application testing and the rancher testing basically. So this is how the script, I have provided my script in the GitHub page as well. I will share the link as well for that. Then afterwards, yeah, so I'll quickly move forward there, and I just executed the script. So basically I will explain the hem command, how it works basically, because it is required. So hem repo add, first we need to add the repo where your application contains basically with the specified URL for that. then I'm using the parameter upgrade dash dash install, because if the application is already installed, then it will simply ignore it. Otherwise, if it is not present there, it will install it. So I wanted to install Rancher, then from which repository I have. So I will install it from the Rancher latest Rancher. The namespace in which I need to, so those are the parameters you can pass with the hem options basically. On which host you are going, which host will be there to endpoint for your Rancher web UI and etc. things. You can give your password. Please don't share the password. I leaked it. I'm sorry. Okay. So you can, there is a wait flag is there. So we can wait for the Rancher to be up and running. So you don't need to wait for the, you don't need to see the logs or something. You just need to see the beautiful screen whether it is there. So I quickly installed it. Okay, sure. I will click. So I have less time. So what I can do, I can simply jump to the Rancher install. So after the Rancher installation, so after Rancher installation, you will see something like that. So K3s is installed. Okay, then there is nothing you need to set up. You just need to execute the command, and that's it. It's just a small script which will does everything for you, and it will have the it will create the service like a normal service in the Linux. Okay, so you can stop the service there itself, like k3s.service, something like that. It is there inside my demonstration in this video, so you can check with that. This is the command you can say, and what you will get at the end. Maybe how, okay, something like this you get, https one, and that address you can paste it in your browser, and you can see this certificate. I told you cert manager is required to give the certificates for your Rancher, right? So after adding this thing, quickly move to the part. Okay, so here I mentioned, I'll just quickly cover this stuff. Here in the Rancher, this is the Rancher UI basically, and you can see this is local cluster. So by default, on which system, on which Kubernetes cluster K3s I am running, my VM act as a local cluster there. So we don't need to use our local cluster. It is just for the orchestrating the Rancher stuff, but we can use the imported cluster. Okay, the cluster on which we can run our applications there. So this is imported cluster. Why imported? Because already I have this in my on-premises. So this on-premises cluster, I just imported it here. So we have option to create it as well. Create the clusters. You can see here, this is import cluster basically, and this is the create thing. So these are the options from various cloud providers. You can use that basically. Okay. So I'll quickly move to the okay, so as I said that you can use the fleet option embedded into the Rancher itself. So you can simply, yeah, where I made this time. Okay, so this is the Git repo page. So where you can mention your Git repo over here. That is, you can add name, then your your application resource URL, where your application resides basically on your GitHub repository. Then mention the branch. So you can mention your tags as well, or maybe revision as well. So there is no need to worry about that. Okay, I need to specify the branch every time. Then you can have multiple authentication ways. If you have your version control system like GitHub or something, a private GitHub or GitLab or any instances in your premises, you can use this Git authentication. Then if you have your hem application, okay, where you deployed it and it is very secure application like banking sectors or etc things, then you can mention the hem authentication as well. And similarly, the CA certificates for that, TLS certificate, if your application requires those things or something, you have like a very restricted environment, limited network environment, so you can use that as well. And then we have resource handling. So enable self-healing, and they always keep resources. Even if you delete this Git repo and you wanted to keep your application running inside your Kubernetes, you can check this checkbox, and you can use this enable self-healing, which will allow you to not altered by any of the system. As I said that Rancher has the RBAC control. So if one senior developer has deployed application with the 3 deployments or something, and one junior developer comes with no experience or something, or recently joined, and he just lowered the deployment from 3 to 5, or maybe no, not 3 to 5, 5 to 3, and accidentally updates your existing application configuration. So this option will restored it to the back original position, what your application is installed in a original state basically. So this is how I have explained. So for this FOSSASIA, I have created this URL called uh, GitHub, my username, and the FOSSASIA 2025, where I have these two applications present, Nginx application and Grafana Him application, just to showcase that normal YAML file of your deployment is also supported over there. So you don't need to worry about like specific structure that you have to maintain or something like that for the applications to be hosted on the GitHub basically. So then afterwards, you can see the main branch or things we can do that. This is how I have shown the mapping over there, how I mapped the, okay, I forgot to tell about this path. So path is basically the path of your application on your GitHub repository basically. So what happened? Sorry. Okay. Yeah. So this is what, and this is I was talking about my application. This is Nginx application, which looks like this. It is a simple deployment that we in the Kubernetes create, right? kubectl apply dash dash something like that, or maybe the simple command that we can get the template of the Nginx application or any application there. So simply I have here deploy to targets, where I can target my application to install on no clusters or available clusters or group of clusters or etc. things. That is another management thing for you guys. I will recover 1 minute. I'll just cover up. Thank you. And this is how your application created. Okay, I just had this Nginx application on my GitHub. This is how the GitOps works in that basically. So right now, for the demonstration purposes with the limited resources, I have 2 K3s clusters running on my system, and this is how I can quickly come up with my 13 minutes of video, okay, or 14 minutes of video, right from the installation to the end of the application deployment via GitOps. And you can see the deployment is there in the specific namespace, because I have default namespace called Nginx there. I can use this default namespace option to install it in the custom namespaces as well, just to manage your namespaces under the Kubernetes itself. So you don't need to worry about that your application is installed in the default namespace or in the another namespace or something like that. And lastly, I can just this one is required, something else. Yeah, you can see that this I have changed this thing with the 3 deployments, and we can see that the deployment is updated there. Where it is, I just need to find that one. Yeah, yeah, see, I have in the video you can see that I have updated my deployments in the GitHub itself, not in this rancher. So it is updated to the 3. You can see here earlier it was 1, so now it is 3 again. So now I am changing it to the 1, I guess, and then it is still it is immediately applying it. So here I have changed, here I have made the changes. Then afterwards you can simply see it here. The applications are like yeah, see here, immediate effect is there. So you can find it seamlessly updating your application as soon as you update the GitHub there. Yes, thank you very much for that. Maybe thank you slide is there. Yeah, yeah, you can come, you can come. Q&A, we can handle it offline. Sorry for time thing.
Okay.
Yeah.
Thank you very much.
Yeah.
And so the next, yeah, thank you for this. And for the next session, it will be about our journey from Git flow to tank-based development. So this session will be delivered by Ludovic Troyson, Chief Technology Officer from NFQ. So he is a leader and specialized in the cloud native technology. And please welcome Ludovic here. Okay.
Jason was saying we can just plug in. The speaker needs some updates, right? So we can just plug it in directly.
I know we're a little bit. Yes. Just give me 2 minutes. We are setting up everything. Cool. We're just loading the slides. I hope you had a good evening, good morning.
It's you first.
You want me to share my laptop?
No.
Okay. It's all right.
No. This your session? No.
Yeah, it's a 10:05. No.
No, it's not 10:05.
I think we're just a little bit late. That's why.
Yeah.
Oh my gosh.
Yeah. This is your.
Okay. So actually in this session, we're going to speak about how we can deploy safely on Friday. I'm taking some risk because we are Friday and we start to set up things. But I'm confident that we will solve the issue. I have my laptop. You want me to use my... Okay, let's do that. Okay. Yes, this one? Yeah, this is this one. Someone delete? Okay, cool. Awesome. Okay. Let's do that.
Did it work? I will look for the screen.
That's okay.
You can
Yeah. No worries, no worries, no worries. That's okay. No problem. Okay.
I will connect the screen.
Yeah, just a second. Okay. Just a second. Okay. Up. 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 Okay, okay. All right.
Wait, let me connect the screen first. Training room 1, right?
Okay. And you should.
Okay, you have already.
Okay, and here, I think we should do that. Up, up.
And this one, right?
Yeah, absolutely.
Slideshow. Yeah, okay, done.
All right, good morning, everyone. Like I mentioned, we are Friday, happy to have you here. And in the next couple of minutes, we're going to try to address two problems that I believe are critical when we want to build high-performing teams. And I guess we need to wait for the live. Awesome. Cool. And like I mentioned, the two questions I would like to address with you in the couple of 20 minutes. First one is, how can we stop struggling with releasing software or going live? Very connected to today. And second of all, how can we deploy on Friday without freaking out, right? So very up to the point. My name is Ludovic. I'm working as a CTO at NFQ. We are a software development company. I'm based in Vietnam. We have been working for 20 years building software, supporting startups. If you have any question, if you are curious, let's talk after this session. All right? Actually, when we start a project, it's a little bit like the New Year resolution, right? Every year we make promises. We want to do things correctly. We want to set new process, new tool. We don't want to repeat the mistakes from the last project that we got, right? And one of the very structuring decisions that we usually take is to choose which branching strategy we're going to use on the project, right? But when we make this decision, actually, it impacts the way we are going to collaborate as a team, right? It impacts the way we collaborate because this Git organization, this branching mechanism will define how we work together, who is owning the code changes. My slides are broken. And then the code stability as well, right? The way we handle, accept changes, refuse changes, so it impacts that. And of course, the way we are going to release the software, right? A couple of years ago, we started a project and we use, I'm sure you are all familiar with it, a branching mechanism called Git flow. It's very popular, especially in the open source world, to manage contribution from untrusted contributors, right? You work with so many people, you don't know them on a daily basis. You want to organize the flow in a way that you can control the modifications that are provided to your software. The principle is very easy. Basically, you rely on isolated branches. You have a couple of long-living branches. The master branch actually is the stable version of your software in green, right? Nobody can actually directly commit to master. It's prohibited. In case you want to develop new features, you are going to work on the develop branch in orange. On the daily basis, as the developer, if I want to change something on the software, I will create branches, I will make modification, I will submit this modification to the develop branch, right? In case I want to fix a bug, I will open another branch called hotfix. I will pull my notification, I will try to fix the problem. And ultimately, if I want to release a new version of the software, again, I will have a tag with a dedicated branch. So here, when we do Git flow, actually, we want to isolate branches. It's very similar. Well, some teams, they like to use this mechanism as well to manage environment, right? They want to isolate the environment and they think it's a good idea to say, look, I'm working on a feature. I want this feature to be tested. So I will push my modification to QA and then the QA will test it. And once it's tested, I will merge it to staging and to prod. Okay? Don't do that. It's a terrible pattern. So when we do Git flow, actually, if we come back to the principles, what we want is to have a strong code isolation, right? I want to isolate the modification into long-living branches, right? I want to connect, to isolate, and I want myself manually to accept or to refuse changes. And it may happen that sometimes, yes, we have branches per environment, all right? A couple of years ago, when we start our project, actually with 5 people, we thought it was a really good idea, right? 5 people, people know well each other, let's start doing that. Like you might guess, at that time, it was manageable. On average, it took us 1 hour to release a software, right? It's 1 hour to merge everything, to prepare the release note, to test, to inform the people. It was manageable. On an average as well, we had very few modifications between each release, 50 commits, 50 changes, quite manageable. And as well, we were able to deploy almost every week. So no problem, right? The stakeholders were happy. But as you might suspect, as the success is coming, you start to increasing the number of people and you have more developers in the team. And you add a 3rd team, and then you add a 4th team. And then you reach a situation when, with using Git flow, you slow down completely your release process, right? With 20 people, it took us up to 9 hours just to deploy a single release, right? We had to freeze the code, no modification allowed. We have one guy who was responsible to merge all the modification and to deploy. Every release involves a lot of changes, and each changes create some instability on the software. And we were not able to release so much frequently, on average every 2 weeks, right? So as a leader, when you talk to your stakeholder and you try to explain, okay, now we have 20 people, but we release much slower than before. Then, of course, the question is like, guys, what the hell is happening? What are you doing, guys? 20 people, and now you deploy even slower than before. It's completely unacceptable. So what actually is happening? When you use a Git flow at this scale, you face what we call the merge hole, right? It's like a little bit on this picture. You have so many roads running in parallels, so many intersections, so many changes that it's become super, super hard to merge the modifications, to handle the conflicts, because everybody is working in an isolated environment. And the reason is because when you do Git flow, by definition, you are not doing continuous integration. I think it's a huge confusion. We think that continuous integration is about automation. Do I have Jenkins? Do I have CI? Do I have pipelines? But continuous integration is not about pipelines. Continuous integration is not about basically having automation. Continuous integration is a little bit like on this car. Everyone is contributing on the same code base at the same time. And everybody is contributing to a specific pieces that together will deliver an outcome. When you isolate by branches, basically, you prevent, you delay, you postpone the integration because everybody is working on a different car, basically, right? We had as well an issue that I will explain is that we had some lead time. By using Gitflow, it took us a lot of time because, yes, of course, you need to wait for the environment to be available. You need to wait for the QA to test. Basically, by isolating the modification, we had some lead time. And it's also connected to the fact that, again, when you do Gitflow, you don't do continuous deployment. Continuous deployment, again, is not about automation. It's not about scripting. It's not about pipelines. It's about the ability to continuously, with little effort, to be able to deploy a new version of your software somewhere. If you have to do it manually by merging a branch, it's a problem. Okay? So now the question is, what can we do, guys? Okay, we have every commit, every merge. It's a little bit like this on the picture. It's a hell of a nightmare, right? What we can do, of course, is maybe to simplify our branching model. Maybe this is what we can do. Maybe we can simplify it. And one way to simplify it is to use what we call trunk-based development. So a different branching model. It's not new, actually. It has been an extreme programming approach, very popular over the last 20 years. And the principles rely on the following. Instead of having long living branches, I will have a single branch called the main, the master branch, or the trunk. Everybody is going to work on this master branch. We allow to have temporary branch that are short-lived, but they can only live up to 1 day. Okay? So we force basically everybody to work on the same branch, and we allow them temporarily to have some short-lived branch, but they can only last for up to 1 day. Okay? At the end of the day, they have to merge back their modification. So we have a trunk. This is a single point of truth. The master branch should be releasable all the time. This is the stable version of the software. Second of all, we allow only short-lived branches. And of course, these branches, they need to be merged back to the trunk every day to minimize basically their life duration. Okay? How do we implement that? Basically, we need to change completely the mindset about how we process things. Instead of releasing a bunch of tickets, a bunch of commits to production, every single commit, every single change becomes a release. Every modification you make to the code, it gets deployed directly to production. It's directly moving towards the trunk, which is a single proof of truth. Okay? It means that as well, we need to have very short-lived branches, no more than 1 day, right? And in case we have work that span over a day, we can use feature flags, basically, to have this intermediate stage. Okay, so it means that in case you have work that span across a day, of course, some features are much more important, then you will use a feature flag to temporarily wrap your code in a space, and you will still deploy your code to production. The other colleagues of your team, they will have access to your in-progress modification. This is how you achieve continuous integration. Okay? I must see some of you are kind of like raising their eyes and say, wow, means that now we produce dirty code to production every day, it's not finished. Sounds a little bit weird, right? So let me explain a little bit. Yes, we need to shift the mindsets of our engineers. When we want to achieve trunk-based development, it's important to sit with your team and to explain, yes, this is okay to deploy to master. Yes, you have the right to actually write to master directly. It's not a problem. But you can only do that if you understand what is a story, what is a commit. So minimizing the size of the commits and the stories. Additionally, you can only do that if you instrument properly your pull requests, right? We need to merge back to production every day. It basically means that you need as well to review your code on a daily basis. And you cannot just sit in a pull request that is going to wait 3 days to be reviewed by one colleague. So what we did in our team was to highly automate the pull request processes and as well to block some time every day. So every day, today, from 2 to 3 p.m., people are reviewing the code of each other. It's a synchronous process when we block time together, allowing us at the end of the day to merge back the modification. Okay? And of course, you need to insanely basically rely on automation, right? I guess you are aware, code review is not about styling. Okay? Code review is about code logic, architecture, correctness. It's not about styling, all right? And finally, we need to have a pretty rock solid build processes. If you have no test suites, don't try trunk-based development. If your build process is more than 15 minutes, don't try trunk-based development. So you need to have a couple of enablers in order to move toward trunk-based development. And if your build process is not rock solid, this is the first step to improve and to change. Okay, so our build time today is like 5 minutes, and we have a code coverage of 82%, which is confident to do trunk-based development. Otherwise, we would have never done that. Okay? So a little bit earlier, I say, okay, look, we have some unfinished feature. I'm working on something complex. You ask me to merge back to master branch every day. How does it work? Right? We have some unfinished business that we need to handle. How is it possible? What we use is a concept called feature flag. Feature flag is a little bit like this switch pattern. We turn off and we turn on some features, feature flag. The way it works is, let's imagine I am a front-end developer. For some reason, I'm working with a backend colleagues and he's a little bit slow to finalize the API. I have finished my components. This is the blue component, but I don't want to wait him to be ready. So instead, what I'm going to do is that I'm going to wrap my code in a Boolean, a feature flag, and I will just push everything to the production, right? And in 1 or 2 days, when the backend developer is going to be ready with his work, he will just pull my branches, he will enable the feature flag, he will finish his work, but I don't have to do anything else, right? I have done my work, so I'm not waiting. I am not starting a new ticket and maintaining a long living branches waiting for him to be ready. I just wrap my code in this Boolean and I allow it to move faster, okay? It works exactly the same if I am a backend developer, right? I work on a complex algorithm and I want to optimize something, but of course, I want to provide some transparency to my colleagues. What part of the code base is going to be changed? What are the impacts? Then I'm going to wrap as well my code base in a feature flag. And then I don't impact the work of others, right? They will see directly what I'm going to do. And at some point, I will be able to turn on this modification. So basically, the new algorithm will be used. I can do some A/B testing. And in case it's not working, I can immediately revert back this feature. So it's very, very a runtime enabling feature enablement. Okay. Of course, we can use that as well if we are a product manager, right? You are all familiar with Grab. I'm living in Vietnam. Last year, I was in Da Nang. It's a beautiful city in the middle of Vietnam. Highly recommend. And as I was ordering a Grab, I noticed that actually there was this small notification at the bottom. Actually, Grab was basically beta testing a feature, but only on all the users that were located in Da Nang. And actually, this is also a very good way to do A/B testing. We can use feature flag actually to release some feature by targeting some specific audience, user, location, country. And then suddenly you use feature flag as well to target a specific audience, to collect feedback. And it's very useful as a development team to start to approach that, right? Because you start to be very tactical. You start to say, look, we don't need to have the whole feature ready. Let's just deploy it somewhere for some specific users, for some specific profile. And if it's not working, we can just disable it. We can just revert. But at least we don't start long process of working on the feature. All right? So if we summarize the feature flag, it's a little bit like on this road, right? We are working on a feature. It's not finished, but people can still walk next to the road that is in progress. It's really this state where I am able to deploy non-ready feature to production. But actually what it means is that when I enable feature flag, it's really like dynamic, right? I don't have to wait 5 minutes. In case it's not working, I click on a button, it's finished. And when we do that, actually, you start to realize that, okay, maybe we are deploying to production every day, but maybe we are not releasing to production every day. Yes, the production received the new version of the code base, but the feature is not enabled. Nobody access to it. So yes, we deploy every day to production, but we are not releasing every day to production because the release process consists in turning on this feature. So when do you apply the feature flag? 3 aspects. Here, you put it in the user interface. You just want to hide components, right, or pages. Either you put it on your API endpoints, right, with a payload or with an endpoint, or either you put it on the business logic, right? Depends a little bit of what you want to do. Of course, you need to consider the security aspects. If you hide a component and you call an API, but this API is not blocked as well, you have some issue. And of course, you need to test it. Today, it's forbidden to deploy a feature flag to production if you don't have test coverage. What is happening when the feature flag is enabled? What is happening when the flag is disabled? Of course, feature flag can go very, very wrong. Okay, it sounds easy like that. Can be very good professionals. I just want to highlight an interesting story. 10 years ago, there was a very famous company in the US. They were working on the stock exchange, right? And there was a change in the regulation, and they had to change and to update a dynamic trading algorithm. This algorithm was making financial order on the stock exchange. These guys, they were absolutely brilliant, very smart, very professional, very organized. They said, look, let's deploy it granularly with a feature flag. So they implemented a feature flag. They upgraded the trading algorithm. They tested it. It was documented. They enabled it. The problem is that they deploy their code base on a couple of machines and they reuse an old feature flag. So they deploy the code base on 8 machines by reusing an old feature flag. And the problem is that they forgot 1 machine. And then suddenly the latest machine re-enable an old portion of the code base, which make crazy order for 45 minutes. In less than 1 hour, basically, they lost almost $500 million because the system was making crazy order. In 2 days, the company was bankrupt. They didn't have any cash flow. They just have to close completely their business. So yes, feature flag can go wrong. And I will be happy to share with you some recommendations if you want to go this way. First, you need to use them as little as possible. More than 15 or 20, good luck. It's really hard to manage in terms of combinatory, so don't do it. You need to place them as high as possible. Don't try to have different feature flags embedded into each other. Doesn't make any sense. They need to be battle tested. There is no feature flag that you can deploy if you don't have a unit test that is covering them. All right? You need to be documented as well. What is happening when the feature flag is enabled? What is happening when the feature flag is disabled? Who is responsible for disabling it? Who is responsible to enable it? You need to document your approach. You need to remove them at some point when you are finished with that. So today we pay back the feature flag at least 2 sprints after. And you should never, never, never reuse them. Once they are finished, you just forget about them. You never reuse them. All right? So to summarize, what we did basically was to simplify the branching model, moving to train-based development. What we did as well was to decouple releasing from deploying to production using feature flag. I didn't mention today, but we also use ephemeral testing environments. It's another part of the conferences. And that's it, basically. So if we come back to the summary, we move from this kind of like weird situation when we have one guy who is the god of Git and he's able to handle the merge 1 day per week to a different situation when at the end we were able to release in 50 minutes. On average, each release took only 10 changes and we were able to deploy 2 times a day. When we step back again and we look at the metrics, before basically the adoption of trunk-based development, we were able to deploy like 2 times basically, or let's say 1 time a week. And we managed to multiply by 3 the number of releases using this approach. On the top week, we were able to deploy 13 times to production. On the top day, we were able to deploy 6 important features to production on the same day. And on average, we only have 7% of defect rates, meaning out of 100 release, 100 deployments, we only had to roll back 7 of them because there was an issue, right? So it's a little bit the metrics we were looking at the time. Okay, excellent. Couple of challenges. You will have to support the engineering mindset, okay? When you start to have developers working on master, they start to be very uncomfortable. So you need to define and to sit with them. What is the definition of ready? What is the commit size? You need to encourage ownership among developers. You need to change probably your team structure because suddenly you work at the different pieces, fast pace. I highly recommend as well to support this adoption by using workshops. Sit with the people, let them try. I highly recommend to challenge every sprint planning. Small is not enough. You have to challenge constantly what is a small story, what is a small step, what is a small increment. I highly recommend as well to monitor the trends, to conduct retrospective. Are we going down? Are we increasing the number of bugs? And I highly recommend to provide guardrails as well to automate, encourage, protect your team. Product development versus software development. This approach is only valuable if you want to deliver fast, if your survival depends on how fast you can ship feature. If your goal is to deploy a very stable software and you just deploy every month, every quarter a release, probably trunk-based development is not for you. So you have to choose what you want to prioritize. Are you working on a product and you want to release fast features because this is what the market is expecting from you, or if you want stability? 2 excellent books that I highly recommend: Accelerate, it's a Bible, and the Unicorn Project. Absolutely fantastic books. Highly recommend. 2 seconds. Thank you so much for your time. If you have more questions, no, I'm kidding. Now, Accelerate is a really good book, very theoretical, and the Unicorn Project is more like a novel. It's very, very distracting. If you can't sleep at night, highly recommend. And thank you so much for your time. We don't have time for questions, but I will be up there for a coffee if you want to know more. Thank you so much.
Thanks a lot, Ludovic, from the session about the Git flow. Yeah, and so while we waiting for another session to set up, I would like to introduce the next session from Kim Sear and Vikram about a self-healing pipeline. How Dagger plus LLM are making traditional CI/CD obsolete. Wow, interesting. So please welcome Kim Sear and Vikram. Yeah.
Yes.
Okay.
Thank you. Thank you. Vikram, do you want to use which one? I think that because that one. Okay. I have. Oh, you have 2.
Side first. Yeah,
I'm okay to use
and
that.
also present the entire screen
Online. Oh, I see.
and the entire screen. Yeah, click the screen and share.
So, of course, this for this
First
session,
step.
we will learn more about the Dagger, which is a programmable CI/CD with large language model to create a
How do I go
paradigm
forward?
of self-healing pipeline. Yeah, and a bit of background for the Kim Sear and Vikram. Kim Sear is working as a developer at Upcorin.
Yep.
Yeah, Upcorin in Singapore. And Vikram is for Dagger.io. Without further ado, I will give the stage to them. Thank you, please welcome.
Thank you.
Can you please take some
Hi.
photos?
My name is Kim Sia. I'm from Singapore. I'm a developer, and this is Vikram here. He's an open source enthusiast and developer consultant with Dagger.io. He's a published author of 7 books, and this is our first time collaborating. We met through Discord, on Dagger Discord, in fact, and 2 years ago we catch up for coffee, and next thing we know, we are presenting this today for the first time. So, Vikram.
Hey, Kim here.
Hi everyone, welcome to our talk. Like Kim Sia said, we actually planned this talk. We met over coffee, and we were thinking about self-healing pipelines. And this was in December, so we proposed this talk. And actually, things have moved so fast in the last few months that this actually became a reality. It was actually quite an interesting experiment that we built. Before we start, I want to talk a little bit about the title. Like we're saying, this is a self-healing pipeline. Just explain a little bit what that means. So if you're a developer, imagine a scenario, you add a new feature to your code, you push it to your repository, and you have a CI pipeline that gets triggered, right? And that CI pipeline is going to do a bunch of things. It's going to lint your code, it's going to run your unit tests, your integration tests, it's maybe going to run a build, maybe it's going to upload an artifact to a registry or to a remote storage. But if there's a mistake in your code, all that will come to a stop, right? The pipeline will fail, and then it's up to you as the developer to figure out, hey, what went wrong? I need to debug it, and I need to make some changes so that everything works. And what a self-healing pipeline is that it takes away a lot of that work from you. It's actually going to on its own investigate what happened, and it's going to come back and it's going to give you suggestions, or it's going to make the fixes automatically, so that your test pass and your pipeline works. And I know this sounds a little bit futuristic, maybe science fiction kind of thing, but with an LLM, this is actually reality today, and we're going to show you a demo actually of it in action. So that's about the topic. I'm going to turn it over to Kim Sia now, and he's going to talk a little bit about CI pipeline.
Right. Thank you, Vikram. So hands up, anybody understands the concept of continuous integration, CI? So that's most of you. Thank you very much. For the benefit of those who are a little bit not familiar, even though Ludovic covered it brilliantly just now as an overview. So continuous integration is about the speed at which you want to deploy the software, like I said very brilliantly. And we all started in a very simple manner, right? Maybe a few scripts in the beginning, maybe we use something like Ansible, Playbook, that sort of thing to help us quickly package our software and deploy it. Now, usually we have three types, right? Mobile app, a desktop app, or web application. Now, the first two, we probably need to package it into an executable installable executable package. The third one, we want to deploy the software to some web server, right? So we would like to keep things simple. So over time, we would add more things, like maybe we want to automate our lint check, our unit tests, and things will start to become a little bit more complex. So, sorry. And that's when we start to see the image on the right-hand side, right? So things have become more complex for our continuous integration script. And as time goes by, especially now in the age of automation, we will now introduce AI agents and LLMs into our CI process, because we all want to be more productive, right, as developers, and that actually adds more chaos, and we need to work with different teams. Maybe we need to work with QA, and things become much more chaotic over time. And what's wrong with CI can really be boiled down to three main factors. Number one is that what we call reproducibility. Does hands up for those in the audience? Does this look very familiar to you? Yes, very much. Okay, we call this the push and pray, right? The push and pray. It works on our laptop, but we are not sure if it actually works in the CI server. So we push and then we pray very much to the gods of CI servers that yes, it will get past our Jenkins and what have you, right? But after a while, you have to try the second time, and then the third time, and then the fourth time, and the fifth time, the sixth time, and so on. So you probably get the idea, right? The second type of issue we have is, maybe your team originally started off something simple on GitHub Action, but it's still not enough, or maybe your team wants to cut costs. They want to move you to something even better and cheaper, like a Circle CI and stuff. So you may have issues migrating your CI scripts from one provider to the next, right? So that is our second problem, portability, right? And the third problem we want to do, so when we are trying to port over, we want to keep both, because you cannot just swiftly just migrate easily, right? So portability is an issue. Now, the third thing we want to do is complexity. So on my right, your left, day one, you've kept things pretty simple, easy to read, Now, over time, as you add more changes because your software is taking off, you're going to add more steps to your CI process. Things become more complex, and so on and so forth. So now it becomes very hard to find out what went wrong during your CI process. Is it something on your script, in your automation script? Is it something on the CI provider? Is it something that occurs between the interaction between your script and the CI provider? So that becomes very opaque and hard to decipher. So these are the three problems of CI processes today. So I'll hand over to Vikram, who's an expert in Dagger, to tell you more, because Dagger allows us to set a foundation to have solved those three problems that I pointed out earlier, and also allow us to take advantage of the immense growth in terms of LLM automation. So back to you.
Thank you. Yeah. Oh,
Yeah.
okay, thank you, Kim Sia. So that's a really good description of some of the problems and some of the patterns that people are seeing in CI today. Some of the frustrations that a lot of people in this room have probably experienced as well. So I want to talk a little bit about Dagger. Dagger is an open source tool. It's actually been created by the founders of Docker. You see them in the photo over there. And this is kind of how we describe it. It's an open source tool which lets you build composable workflows. And those could be CI workflows. It also works for AI workflows, any kind of complex workflows which need to be repeatable, work consistently, and be completely debuggable. So I want to describe a little bit about it. So some of the key features, containerized workflows. So everything, all workflows in Dagger run in containers. Because they run in containers, they are immediately reproducible. You can run them on your laptop, you can run them in a remote server. They're always going to work the same way. So a lot of the, the slide that you saw earlier, the works on my laptop problem and the push and pray problem, they're just eliminated because of this. Because if the workflow runs on your laptop, it runs in a container, it's going to run the same way wherever you run it. We have in Dagger, we have what we call a universal type system. So your Dagger workflows are made up of functions and modules. And those functions and modules can be written in any language. And not only can they be written in any language, but you can plug and play those modules to create your workflows. So for example, let's say you have a workflow which needs to, at the end of its process, needs to upload an artifact to S3. And there is a Dagger module written in Go, which does that job. But your app and your pipeline is written in Python or in TypeScript. You can actually plug that Go Dagger module into your workflow and just use it natively in code, just as you would write normal Python or TypeScript code. The next thing that we have is actually another one of Dagger's superpowers, which is caching. So every operation in your workflow is cached. And that means that when you rerun that workflow, the steps which were the same, they just, sorry, I need to get the, okay, yeah. Those operations are cached, and this caching works for both LLM calls, API calls, all of that. And so that means when you run your workflow the next time, the steps which are cached, they're just pulled from the cache. So your workflows are going to run faster. And for example, for CI pipelines where you're charged in in seconds or in minutes, because they run faster, they're also going to cost less. We have built-in observability. This is a key feature for debugging. So I'm going to show you a little bit in the demo, but Dagger gives you logs, metrics, complete traceability of the workflow, so you can see exactly what is happening at any given time. And you can also share those debug traces with other members in your team, so people can collaborate and work together to figure out what's happening. It's a completely open source tool. All our code is on GitHub. We do all our development in the open. So you can drop by a GitHub repository. You'll see things that open issues, things that our team is working on. You can contribute. You can write an issue if you have a problem. You can contribute solutions, open pull requests, and all of that. And also, because it's a completely open platform, you have all those benefits of openness, right? You can experiment very freely. You can you don't have any vendor lock-in. You can switch from one CI provider to another. You can switch your tech stack. You can do all of those things very easily. We have native integration with almost all the LLMs that are available today. And integration is actually very interesting because when you integrate Dagger with an LLM and you give it your workflow, it can automatically explore that workflow, explore the functions available in that workflow, and start actually operating and using those functions with the LLM augmentation. And finally, we have interactive terminal. This is again a very powerful debugging tool. You can drop into your workflow at any point, see the state of your containers, see the state of your services, even make changes if required, and it helps you debug things a lot faster and get things working very quickly. So this is kind of everything that makes up Dagger. It's a big diagram, so I'm just going to point out some of the things. So at the core of what we have is the Dagger engine. This is a specialized engine for running workflows, and you interact with this engine using SDKs. So we have officially we have 3 supported SDKs, which is Go, TypeScript, and Python, and that means that you can write your pipeline in any of those languages. So you write your pipeline in code just like you would write your application in code. You write the pipeline also in code. You can pull in. You have access to your entire languages ecosystem, so you can pull in third-party modules from npm if you're using TypeScript, or from PyPy or any of those things. In addition to the officially supported 3 SDKs, we also have community-generated SDKs. So we have community SDKs for PHP and for Java, and there are other languages also which are being developed. And if there's a specific language that you use regularly, which you don't see an SDK for, as I said, we are completely open. You can hop into our Discord and you can start developing an SDK for that language and contribute it back to the community. Coming to the left side of the screen, we have Dagger is completely vendor agnostic, so it works locally on your laptop. It works with every CI provider that's currently available. It's also very easy to switch from one CI provider to another. With this kind of addresses the portability issue that we talked about earlier. At the top is Dagger Cloud. Dagger Cloud is our web dashboard for tracing your workflows for debugging. And I'm going to show it to you in a little bit, but it's basically the tool that you would use to understand what's happening in a workflow, to identify errors, to collaborate with your teammates on figuring out what went wrong and how to fix it. And finally, on the extreme right, we have what we call the Daggerverse. I mentioned a little earlier that your workflows are composed of Dagger modules and Dagger functions. And those Dagger modules and Dagger functions can be published online in a catalog, which is called the Daggerverse. And that lets anyone search for a module that does a specific thing and just plug it into their existing workflows. So these are user contributed modules from the community. They are all, you can go in and you see for each module, you see what the API is, you see some examples of how to use it, and you can obviously inspect the source code as well.
Right. Just to quickly add on, as a developer, I'm not with Dagger, but the way I discover it is because I really hate writing the YAMLs and learning all the syntax. We all prefer to use our own preferred language, right? Like, for example, I prefer using Python, and that got me interested because I could easily use their SDK to write my own CI process. And that's how we got to start talking about it. So this is my favorite part of the whole platform.
Yeah, so the interesting thing is that if you're writing your Dagger pipeline in any of the supported languages, you're writing it in your IDE. So you're getting all the IDE benefits as well, like you see the auto completion and the code intelligence and the language hints and all of that stuff. So it makes it very fast, very easy. It's a very native experience. So you feel like you're writing your pipeline in whatever the languages that you're most comfortable in. I want to spend like a minute talking about our LLM support. And this is just a couple of code examples. So as I said, we have native LLM integration with almost all the models that are there available right now. And what the way it works is that you can create a Dagger agent which connects to your LLM. You can see it in the right box, and you give it what we call a workspace. And that workspace, you kind of define what the workspace is, but usually it's going to be a container or a set of containers, maybe with your source code or assets that you want to operate on, and you give it a set of tools, and those tools are Dagger functions. So if you look on the left side, you got an example workspace module, and you can see we're giving it setting up a container with some source, we're setting up some tokens, and we have a couple of functions there like test and write file. So these are tools, and when you connect the LLM to this workspace, it can explore the workspace, it can understand what it can do, what are the tools available to it, and then you can actually give it instructions or assignments and say, hey, this is the source code, this is the tools, I want you to do X, Y, and Z. And we're going to show you this as well. So yeah, so that's the main kind of the talking part. Let's get to the good stuff, which is the demo.
Right.
So
I can hold this for you.
okay, thank you.
Right. As Vikram is setting it up, so I'm just do a very quick, brief overview of what's going on. So what Vikram has done is that he has a Python-based fast API sample app. We will share the links with you at the end of the talk. And what happens is he's gonna purposely send in a faulty pull request that will trigger failed tests, and then we will see the LLM kick in to help resolve the issue. Right.
Yeah. So so this is actually this is the simple fast API app. It's just API, REST API with some endpoint, and it has it's a simple API which just lets you add and remove books from a database. And we have a data model. And what I'm going to do is right now, it's all working. So
Happy to hold.
yeah, no, it's okay. So what I just kicked off here is it's a Dagger function called test. And what this test function is going to do is it's going to create a workspace. It's putting the source code of my app into it, and it runs PyTest. It's a Python app. It runs PyTest, and we should see thing to it, so it should be working hopefully. Yeah, and you can see all this, so it worked, right? And now we're going to deliberately put an error in. And what I'm going to do is this is my sorry, yeah, thank you. What I'm going to do is this is my base class for my API, and let's add a field here, right? So we have title and author fields, and what I'm going to do is add a field. Let's make it a little bit more difficult for the LLM, and we make that out. And so this is all I'm going to do, right? This is let's say a junior developer, right? He's done this, he doesn't know what happens, what else he has to do. So he says, okay, cool, this is the change that I'm making. And now obviously let's run that test again. And now in this case, we've added some code, we've not updated anything else. We've not updated any of the other files, we've not updated the unit test, we've not updated the repository. So there's obviously going to be some problem. So let's have a look. Yeah, so you can see as you can see, there are some test failures over there. And so this is the point where if this was in CI, your CI would give you a big red danger symbol and come back to you, and you'd be like, oh, okay, something went wrong. Now I need to go in and figure out, look at the debug messages, try and figure out what went wrong. But we don't do that today, right? Today we're going to have the LLM do this work for us. And so now I'm going to run a different function. It's called heal. And this is the function which actually is going to bring in the LLM integration. And so this is going to take a few minutes because what's going to happen is that the LLM is going to have a look at the code, run the test, figure out what went wrong, and it's going to try and fix it. So while this is happening, it's a little bit hard to read this, but I mentioned some time ago we have this tool called Dagger Cloud, which lets you see exactly what's happening. And so I'm going to switch to the traceability tool so you can see a little better what's happening here. So this is Dagger Cloud. It's a web-based dashboard. And this is actually our Dagger team's dashboard. So you can see our team working on stuff in real time. And this is the function that I just ran. And what this is going to do is it gives you what we call a trace. And a trace is a very detailed insight into what is happening in the workflow. And let me scroll down a little bit. And so this is the prompt that I'm giving the LLM in this case, right? We're telling the LLM, you're an expert Python developer. Here's some source code. Here's some tests which are failing. You fix it. And we're giving it some rules, some kind of guidelines as to what it should do. Make your changes, run the test, keep going, don't stop until the test until the test pass, and so on. And so let's see what exactly it's doing, right? And so the first thing it did was it ran the test. It saw that there are a bunch of failures, and you got a full stack trace. This is the stack trace from the failing test. It's a long stack trace. And this is what the LLM actually analyzed, right? And it figured out, okay, the problem is related to the field that I just added, and it's giving us a plan of action. Okay, it's like, okay, this is what I'm going to do. I'm going to fix these other files. I'm going to fix the test and all the rest of it. And you see, these are the tools that it has, right? It's figured out that there's yeah, thank you. It's figured out that there's a tool called read file, and it's using that to read the files. And as we come down, it gives us, it tells us what it's found, this is what it's found, etc., etc. And then it's also found a tool that we have in the workspace, which is called write file. And these two things are giving it what it needs to understand what's going on and to make fixes to the pipeline. And look, it did it, right? It figured out, okay, this is what I need to change. And it says, this is, I changed, I changed the model, I changed the repository, I fixed the unit test, and everything is working as expected. Let's see if it is, right? So let's go back to my VS Code. And if you remember, I only changed the models.py file, right? This is the line that I added. Now let's have a look and see there are more things that, so you can see the LLM has added this. And if we go into you see it's also updated this file. This is LLM generated fixes. This is my test data, and it's fixed this. And so let's test if it actually does work. We're going to run the test function again. And this will take about a minute or so. I'm not sure if do we have, how much time do we have left?
Less than two minutes. We should give you a break. We don't want to be the ones holding you back from your break. So
yeah, if we can get everyone for about maybe 3 minutes more. So as you can see, this is now the tests are passing. We didn't really do anything here, right? All we really did was tell the LLM, hey, this is broken, you need to fix it, and we gave it a bunch of tools to actually do what it needs to do. So this is kind of a self-healing pipeline, but there is another version of this as well, which we have, right? So this is running locally on my laptop. Imagine if you want to integrate this with GitHub. So we don't have time to show you all of that, but I'll quickly show you something that we ran a few minutes ago.
I hold it.
Okay. And so so this is an example of the same code, same application on GitHub. And what I did was I opened a pull request with a change, and it was a deliberately breaking change, similar to what I just did. And we had the LLM run over there. And in this case, because it's a pull request, you could also have it change. But instead, what we did was we just asked the LLM in this case to review and to provide feedback on the pull request. And if you look, it did pretty much the same thing. It analyzed the code. It gave us a proposal saying that this is broken. This is what you need to fix. And not only that, it also generated a diff for us. So if you're we all like to be lazy programmers, right? So in this case, you just take the diff, you apply it to your code, and things should pass. So
I guess that's a signal
I
for
guess
us to wrap it up.
oh, it's back. Okay, we're just going to say the LLM is watching us right now. The AI is watching us and wants us to shut down. But yeah. So that's actually the end of our talk anyway. So let me just put up some links here. So for those of you who are interested, if you'd like to learn more about Dagger, please join our Discord. I'm in the Discord. Our whole team is in the Discord. You can ask us for help, or if you need, just some guidance. We have a quick start, which gets you started on all of this stuff. And if you'd like to try this demo app, you can just clone it from there, and you can try it. All you need is an LLM key, like an OpenAI key or an Anthropic key or whatever. Plug it in, and you can try the demo on your own laptop. Yeah, and I think we're out of time, but if anyone would like to see a little bit more, understand how it works, we are around. Just come and grab us. I'll be at the back for a little while. Thank you very much.
Thank you.
Thank you very much for coming for the demo. And for the next part, we're going to have a break. Thank you very much for joining, and we will be. It is a 5-minute break, only 5 minutes break. We will come back after 5 minutes.
End off, okay?
Yeah. Let's do a better version too.
5 minutes. Thank you, everyone.
Yeah, we are. Sure.
Hey,
can
thank
speak
you.
to us immediately. Oh, okay. Maybe you can come back later. Yeah, no problem.
Of what? The tracing tool? No, it's not self-hostable. I figured. Oh, thank you. Yes. Okay. Thank you very much.
You're like munching your breath.
Can I run without
Your microphone.
Oh, yes.
Thank you.
Hi.
This log here is pretty much the same. And the same.
Okay, so okay, no problem. I took some okay. Oh yeah, it's มาพี่อยู่ของพี่กี่โมงของพี่ไปใช่ปะมาจากอันนี้โอเคงั้นคือวันนี้จะมีอันนี้เดี๋ยวผมทิ้งไว้ก่อนแต่พี่เพิ่งจอยน้องทำไว้ให้ยิ้มมันคือเข้าวันนี้แต่ว่าเดี๋ยวพี่เพิ่งจอยเดี๋ยวพี่แชร์แค่จอ
She's not detecting.
เดี๋ยวอย่าเพิ่งเข้าแล้วกันเพราะว่าเดี๋ยวคนเขาถ่ายไว้ก่อน
Oh yeah, you can try using this one.
เป็น LED นิ่งๆใส่ชื่อได้เท่ๆน่ารักดี
Okay. Yeah. Oh, we don't think we have PowerPoint on this. Yeah. No, we don't have PowerPoint. Like, this is it's mint. Oh, okay. Yeah. I'll pick.
อ๋อเดี๋ยวนะนี่ไม่ต่อกันเลย
Can we see the slideshow settings?
Hi.
might don't work. Maybe it should be the PowerPoint to show the notes.
We still can.
Only battery low. The laptop has a low battery. The battery.
Low battery.
Yeah. Excuse me. This computer seems have a low battery power.
Thank you for catching that.
Our notes.
Do you have your own laptop with you?
Yes. Yeah.
Okay, yeah, we can plug that in.
Oh.
But I don't
That
know.
will be a lot easier.
But it seems
Don't need HDMI. Wait, we do need HDMI. Yeah, but like so, because we just only office. Wait, so the PowerPoint is okay, right?
Yes, okay, but you can see our notes.
Oh.
I don't know whether the demo video can show normally. Oh no, it became a picture.
It's okay. It's okay. Oh, it's okay. Just see the note in your computer.
Okay.
Right? If you want to hear
It's okay. It's okay. I've stored on my phone. I can see it with my phone.
okay right now.
So we
Good, right?
yes, we're good.
Okay, so we use this one.
Yeah.
Thank you.
And you can see.
Okay, thank you.
Hi everyone, hope you managed to get your snack boxes already. Next up, we've got using Fusion to optimize the software development process. We have to go from Seattle Group and one of them is from Seattle Group as well. We're using platform engineering and solid options. Let's welcome.
Hello everyone. Thank you for being here to join our session. So today I'm Huang and this is Xiaomi from Ant Group. So today we will introduce our tool to optimize the software development process with the internal developer platform. So a little bit about ourselves. So my name is Huang. I work for Retail Group from Vietnam. And here's my information. And this is Xiaomi.
And I'm Xiaomi, a platform engineer at Ant Group from China.
Okay. So
here is the table of content of our presentation. About our agenda today, we want to talk about some of the challenges we have observed, especially the ones that contributed to inception of this project. And we are going to introduce the core concepts of Fusion and the core workflow of it. Then we'll introduce the best practice with IDP and Fusion in ARM group. And finally, we will showcase a demo video of Fusion Server. And I will explain some of the basic concepts in Fusion. And Huang might introduce the core workflow.
Okay, so let's get started. Oh. Any problem? Okay, so everyone in here know about the demo was filed maybe in 2009. Is the working country was born to better collaboration with the developer and operation, but actually is not the current is not used in the right way in many fields. Like it still work fine with a small organization, but with bigger it should actually just like ship as much load as possible onto the developer. And now with many tools, squatting tools in the landscape of the cloud native, and many organizations will increase the cloud adoption. We will have to work with many complex tools. Developer will need to understand the complex cloud native tool. From the as you guys can see, there have many cloud native tools if we have to discover. So as I said, with the small organization, maybe 1 to 2 teams, we will have the in each project we will have the 2 teams like the developer and the operation. But but in the large enterprise, every team will have to have the developer team and the operation team. It will make something like we have the conflict position, and so it make us it will have some conflict where it has to it will be really hard to sync with the technology. Each team cannot be have with each other. And with this will be maybe every developer will become the bottleneck with the developer. So so the platform engineer term was born. Actually, what is actually this team do? So it is will build the internal developer platform for their customer. The customer here is every developer in the organization. So developers will focus on their best practice is just coding. They don't have to worry about the underlying, like how to provision the infrastructure, how to deploy the application. They just working on their best job is coding. So the system will help us to do this. Back to Xiaoming, will introduce a little bit about the Fusion. How will Fusion help us to do this job for platform team?
Okay, so actually we are aiming for the platform teams to define what we refer to as a golden path for developers. This service level looks, this might look intricate, but I'll get straight to the main point, which is about separating the concerns. We believe that the application team positioned at the top should focus on aspects that are agnostic to the environment. Typically, this entails that the application team wants to outline what their workload, say like a container or a pod, looks like, along with their dependencies, such as needing a database of a particular version and size, and without worrying about the specific database provisioners. And on the bottom left side, we envision that the platform team should be responsible for certain tasks. They need to establish a standardized workload profile, whether using Kubernetes deployments or custom workloads, along with defining behaviors like image pool policies. Furthermore, the platform team will also set standards for various dependencies like a database, networking, or object storages or gateway. And here comes the Fusion application configuration. The app configuration model serves to unify the workloads along with their associated components required for application deployment. It also incorporates pipeline and operational necessities into a singular, standardized, and infrastructure-independent declarative specification, say like the pipeline block and the dependency block. This specification clearly reflects the user's intent regarding the application, facilitating a streamlined and efficient process for both application delivery and operation with a hybrid environment. And next, we come to the workspace configuration. A workspace is a conceptual framework that corresponds to a specific target environment used for deploying application stacks. In contemporary usage, this typically refers to a Kubernetes cluster, which hosts the application workload, along with an optional cloud, maybe AWS or GCP, account for provisioning the necessary infrastructure resources, such as DB. In addition to serving as a deployment venue, workspaces are structured to be linked with a set of platform configurations, which will apply to all the stacks deployed within that workspace. Okay. This overview will provide a deeper understanding of the functionality of Fusion modules. We aim to present a simplified explanation of the underlying concepts involved. Fusion modules effectively manage both community resources and some therapeutic resources, translating them into a specification that serves as a middle layer data, which we call as the spec. So this data format encapsulates both resource types. And now it contains Kubernetes and Terraform resources. So platform engineers are going to manage these configurations. Typically, these configurations establish a set of default values. For example, the MySQL module might include a default configuration with a size of maybe 20 gigabytes and an instance class of DB-T3 micro, just show as the right side of the slide. And for specific sectors of applications requiring some customized settings, it is also possible to define overriding configurations. However, this aspect represents a more advanced use case that will not be concerned in the current demonstration.
So thanks, Xiaoming, for the complex architecture. A little bit more easy to get to the workflow of the Fusion. And as you can see, with the platform team, they will work to build the model. what is the symbol simplify of the model here is just about the model to define get the information to provisioning the MySQL database or the monitoring system. So the platform will configure the workspace. The workspace here is about the software environment of your product, like the development environment and production environment. And the application developer will use the app configuration. You just define the basic information of the application, like the image of the application, some environment variable, and some information about the database, and then it will merge it to the system to with the work we will merge with the workspace config to the Fusion engine to to provide to provisioning every infrastructure that the platform team was built in the model, and also deploy the Kubernetes of it. So underline here is just the basic, easy to understand which step will be work for it. So everything will be done with the underlying system. So also the Fusion is also work as the event-driven platform orchestrator, which including in the platform tooling landscape right now. It will use in the main function that's to interact with the resources plan, and it will use to the main function of it actually now is used to provisioning, working with the Kubernetes and provisioning the infrastructure, and also have some feature with the large language model in AI currently right now.
Yes.
That is working on right now, and furthermore, it will have many backend like the many deployment environment next later. And back to Xiaomi.
Okay, and so here is the best practice with Fusion we are running today and Ant Group. So the upper part of the graph, it shows the conventional business application CI/CD pipeline, including the code review, building and publishing the OCI artifacts. And the bottom of this graph just shows a pipeline concerning the configuration codes written in KCL. KCL is another CNCF sandbox project. It's a domain-specific language for especially for configuration. We wrapped the Fusion CLI inside the pipeline, so we can also integrate the IDP with Fusion Server. On the high level of the configuration pipeline, there are 3 steps just shown in the last slide: coding and preview and deploy. The first step is coding, which includes authoring the app configuration file mentioned earlier, which uses the KCL to declaratively describe the application. And after done the authoring, the second step is to use the Fusion CLI tools to detect the impacted applications and check the compliance. And besides, we can use the Fusion to preview the resource changes if there is any prior to actually shipping the application. You might want to catch any surprises at the stage, especially when shipping to the production. And the final step is to actually ship the application by running Fusion Apply with the multi-cloud heterogeneous infrastructures like Kubernetes, AliCloud, AWS, and GCP. Here is a demo video representing a sample workflow of Fusion Server to deliver and manage an application. So here we can manage the configurations with the Fusion project, and instead we organize the configuration codes into the concepts of project and steps. And then we can preview the resource changes. And after the confirmation, we can apply the resource changes. So here we can preview the resource details. And we can create an apply operation. And after it succeeded, we can manage the resource topology with the resource graph. We can see that it has a namespace, a deployment, and a service. And now let's check the app resources, and we can port forward it. And now we can check the app web page. And here is an example to register a new Fusion module. And to instantiate a new workspace. So the workspace will hold the platform configs.
So this is the end of demo. You will, for more information in our community.
And here is the information of our community. As of now, Fusion has over 1,000 stars on GitHub. And we are very excited to have new contributors to join us to build this product. So welcome to join us.
Yeah, Fusion is also the first tool including in the CNCF sandbox and the platform tooling landscape. Yeah. So thank you for being here to watching it. If you have any question,
please feel free to ask us.
Thank you very much. And anyone has a question for this session? Okay, we will go next to the next session. Okay. Thank you, Mr. Chu and Huang.
yeah, thank you.
I just wonder, how do you keep like audit of changes?
Coming up next to the next session, we will look into the observability with LGTM Grafana stack from Jirayut Ningsang, CEO of Opta Thailand. So this talk will be about let's look into the behavior of metrics, drop, and stress to get the insight of the system. And we will using the Grafana stack. Jirayut is the CEO of Opta Thailand, and he has over 15 years of experience in the DevSecOps, container, and cloud technology. Please welcome.
Hello. Okay, thank you everyone. Yeah, I'm not in the good condition today, so yeah, the sound may be a little bit weird, and yeah, please take care of yourself. Okay, today we are talking about the observability with the our GTM. So I'm sure that everyone already using the Grafana, right? Yeah, everyone know about the Grafana. So, but actually, yeah, we are using more like the Prometheus, right? And with the, yeah, everyone know about now is like a Jaeger to do a tracing something. So today I will talk about the governance stack that maybe anyone should looking at it, and I think that's is a good step for everyone to start with the to do the monitoring and observability. So today I'm going to talk about the monitoring and observability and the best practice how to do this. And if we still have some time left, I will show you the demo about what it look like. Let me introduce yourself. My name is Chirayut Nim Sang. My name is Chia. So I am the CEO founder of Offstar Thailand. We do the DevSecOps transformation for like a company is about 9 years already. So the observability is one of the crucial part to do the DevSecOps platform. So now today we will focusing on that part. First, I want to talk about everyone heard about the monitoring and observability. I want to show you the difference between these two things. It's about the monitoring. We try to, like the monitoring, sit there and looking at what is changing, what is the problem. But on the observability part, it's like we're doing a proactive part to, monitoring stuff and try to understand the context. So I mean that the observability is a new form of the how to do the monitoring the system, and I will explain on the next slide. The monitoring, this is like a standard monitor that everyone should have right now, right? That's monitoring at the CPU, memory, the network, the this I/O part. So yeah, everyone is familiar with this. But to do this, if you see the CPU go to the 100%, are you sure that system is going down or not? Yeah, because of that, if the CPU is moving to the 100%, it means that your system is not going down or going slow. So the monitoring part is not tell you anything. So that's why you should go to for the next level of the monitoring is the observability. So the observability is new thing to do the monitoring by combine with the three pillars of the the data that you need to monitor. It's combined with the metric, log, and trace. So the metrics is a numeric, is a graph that you see every day. The log is a text, right? You will see the text that the from your application or from your system. The tracing is a distribute. Distribution means that the data that's when you access to something, you're going to distribute like jump from the one microservice to another microservices. So this is a tracing. So I will go deep down into the each one and show you the example of the observability signals. This is the metrics, right? This mnemonic data. So we combine with the time, the timestamp with the mnemonic data, and we plot the graph from it. So this is a metric. The log this is very small, but this is all the text, right? And it's combined with the time range, so you know exactly that what is the log happening at which time. The tracing, I will go down deep down to this later, but you can see that it's happened is on one request, and you can see that that one request we have the you can see exactly that how many requests is going on or how many the action going on the system, and how long does it take to do that action. So in terms of why we don't monitor it all, because the volume of the observability data, you can see that metrics you can keep like a year or maybe few years because it's really the small data. But for the trace and log, is consume a lot of data. So basically log, you can see that, okay, for in Thailand, maybe keep for the 90 days, but for the tracing, maybe keep it less, like only 7 days or only a month, because it's consume a lot of the volume of data. And furthermore, we talk about the three pillars, right? But furthermore, they are more of the signal that's maybe combined into the pillar later. The other thing is about profiling. The profiling is look more deep down on how you consume the resources on each request. So yeah, you will see this is will be a lot of data. And also, if you go to the dump, if you're familiar with the Linux, you can see that the Linux we have when you're the kernel panic or something, you will have them data, right? And you can see that only one action maybe consume you maybe 10 gigabytes. Yeah, so dump will get everything from the system. So this is another tool, observability signal that maybe will be one of the crucial part later. Yeah, this is for dump. So next, the three things, metric, log, and trace. They are all also to be the signal correlation together. Yeah, we can moving from the log to trace and trace to log. That is the standard way we do the observability. But from the metric to the logs, yeah, maybe we call it the exemplar. This is very new, but yeah, you can moving front and back between the metric and logs with the exemplar data. So let me so now you understand all about the observability. Yeah, that's a metric, log, and trace, right? So let's see that how Grafana LGTM stack going to answer on this observability. LGTM is, yeah, if you're already familiar with the open source, right? You can see we always use it. LGTM, that is look good to me, right? Yeah, you know about it. So yeah, you say exactly. I really like this meme. Yeah, if you only change the code for 10 line, no way it's look good to me. But if you pushing like a 10,000 of the changing line, yeah, look good to me, right? Yeah, okay, that's a some joke. So for the LGTM stack, exactly. L is a log, yeah, G is Grafana, T is a tracing, and M is a matrix. So yeah, this is what is the LGTM meanings. So yeah, it's what exactly like. But actually, they have their own the software name for each LGTM stack, and yeah, we will see. So this is a LGTM architecture. From the plan, from my first start, yeah, you can see that we still combine the others like the Prometheus, the Grafana agent, or OpenTelemetry for this step. But actually, the time is evolved, and you can see that it's evolving into less the components. Now, yeah, we can do the LGTM step in only this. We can use you can see the L is Loki, Grafana Loki. The G is Grafana, right? And the T is Grafana Tempo. And last thing is M is Grafana Mimia. And the corrector they try to combine into one agent is called Grafana Alloy. So yeah, it's much simpler today to do the also observability step with the LGTM. So I will moving fast because I want to show a demo. So yeah, let's see. First, the Grafana is everyone is using Grafana. I can bet you that everyone already using Grafana. No? Oh no. So you are using Kibana, right? Yeah, or maybe the opposites. Yeah. Just joke. Okay. So actually, the Grafana is only the UI. It's a virtualization, so it's not storing any data into itself. But actually, it depends on how you set up that. Like you want to be one thing in the Grafana, like using SQLite, and we can expand to use Postgres and doing the high availability. Yeah, that's a Grafana. And next is Grafana Mimia. Grafana Mimia, I can say that is equal the Prometheus. The Prometheus is for the matrix, right? But you can see that the Prometheus is not designed for long-term storage. So you can see that the Mimia is equal the Prometheus with the long-term storage and scaling. And also, it's equally the Thanos if you are using, or even the, I'm not sure, Cortex or something. Yeah. So the Grafana Mimia, is going scale very well. You can put the load balancer on top of it, and it's and scale. And the crucial part on why you must use the Mimia, because actually why you must use the LTTM stack. I love this stack so much because all the data has been is stored the data on in the object storage. So it means that you can scaling a lot of data. You just only have the object storage, and if you're using cloud, right? Yeah, the object storage is like, yeah, every data is inside and it's really cheap, right? So compare with the other stack that using the real database is consume you a lot of resources and consume on your cost too. So yeah, every stack in the LTTM is store everything in an object storage. So yeah, you can we can compare with the Prometheus architecture that you can see there are no storage to to be the long-term storage anywhere compare with the Mimia that we use the store everything in the object storage. And one thing that I love about the Mimia is about they separate between and read and write. So it means that there are many ways to deploy the Mimia stack, like the standalone, the simple architecture, or even on the distributed architecture. So everything in here you see in here is a microservices. So it means that you can scaling each one. Yeah, and yeah, the big thing is they're spread between the read and write. So it means that yeah, if your system is heavily write, you just only scaling on the right microservices as shown here, or the query and also for the read. Yeah. So yeah, this is normally for this is the architecture, and next is about the graphical logic. The graphical logic is the same. I mean that yeah, every architecture that I love about the LTTM stack, that they have architecture in the microservice. So it means that yeah, if it depends on the context of your system, right? That you are heavily on the right part or heavily on the read part, you can scale that individually. So yeah, you just look at the architecture and yeah, see how to how to scale your system. So yeah, the log here, I mean that everything is stored in the object storage. So I will keep it short this because if you go deep down in detail, but yeah, it's like it have the label like the Prometheus, and you can query the log by label in here. Okay. Yeah, moving fast because it's too deep. And the last thing is about the tracing. The tracing is yeah, as you can see that yeah, this is a one request, and you can see each action inside. Yeah, this we call trace. And if we put deep down a little bit on this, the one trace is combined with a lot of span, so you will know exactly that okay, the trace normally is my by one request, and yeah, what the action that happened inside that request is we call the span. So you know exactly that which one causing your trouble of your system. That if which one is the bottleneck is of the system, like query the SQL or even calling the third-party service. And also the same, the governor tempo is separate between and read and write, and you can scaling each one individually. And also I want to focusing on this, the metric generator, the tracing. One tracing that I will put more in the next slide is they can generate the metrics from the trace. So we know exactly that the experience of the system, that it is slow or yeah, it is going down or not. So yeah, this is one of the crucial part of the Grafana tempo. And last thing is about the monitoring the best practice. When you do the monitoring, everyone always using this is called the use method. The use method is focusing on the infrastructure, yeah, combined with the utilization, saturation, and the error. For this, you will see exactly that how utilization of your system is, and yeah, this is a use method, and you can see that yeah, this is normally we always monitoring the CPU memory and network, this bandwidth or something, or even yeah, in the in the metric way. And yeah, as I said before, this is not not tell you that how the experience of your user are doing with your system. So next, this is I mean, yeah, everyone should doing this. It's called the red method. The red method is focusing on the application. It's combined with the request, error, and duration. So we know exactly how the user interact with system and how they experience with your system. So we know from this, yeah, this one I want to you all to remember that okay, next time when you do the monitoring, when you do the observability, you should focusing on the red metric, not the use method on the utilization. You still have to have the use method, but the red method is like the main part, or we call that it should be the main monitoring on your system. So imagine that, okay, you have this, you have duration, you have error, you have rate, right? And you necessarily that, okay, you look at the rate first. The rate is how many of the user going to request, going you to visiting your system. And then you go to the duration next. Duration is, yeah, how experience, yeah, how many of user access your system, right? And for the duration is yeah, how long it does it take the user can be get the response from your system. And then you see the error next, right? That okay, how your system is doing. And yeah, you will see that's how is error going. So yeah, I have 5 minutes left, so yeah, I'm going to show you some demo. Okay, this is some demo system. I run everything in my Docker desktop. So yeah, testing and sleep at 3 a.m. last night. So yeah, let's see. Want to show you each one. This is a use method. The use method is first. This is everyone familiar with this, and yeah, this is a CPU memory and how is this going with the system, right? Yeah, or the system is use method. And next, use method also we can monitor into like this is all the container running on my machine. So you can see exactly this is consume around 40% of the my CPU right now. And yeah, how memory using about 4 GB. And also for the use method, you can go deep down like you going to the NTX to see that how your web server doing, how many connection doing with the system. So yeah, this is still the use method. And last thing is about the uh, database. Yeah, this is going look deep down into the MySQL query, and yeah, you can see that okay, your database server is how many queries going to happen on your system, how many of the insert, update, delete, and select. So yeah, so this is the overview of the use method that you should have. Yeah, and next about the logging. Yeah, you should have the log as well and try to combine like yeah, this is how to count the error part and yeah, how many of the HTTP requests you can see in here. And yeah, this is a log happen on the system. Okay, so I show you the metric and logs. And last thing I want to show you is about the red method. This is the simple version of the red method. Yeah, this is an application running on my machine, and yeah, you see exactly they have the request at a slash bar and slash full. And let's see. Okay, this is a request like only 2.5 requests per second, and on each duration is costing you about yeah 400 500 latency. And you see exactly the an error. The error rate is about 13%, and I show you the live log here that what is exactly of the the error log. Yeah, what it happened. So this is a simple version. And let's see on the hardware version. This is a Python fast API, and this is the dashboard. You will see exactly what happened on your system and what the experience with the user, right? You will go exactly here. Now, okay, let's take a look at this. and yeah, ask yourself which page is slowest, which API is slowest, is chain, right? So yeah, you know exactly, okay, something happened with the chain is 3 seconds. So next, what are you going to do with it? And you just go explore and try to search for the chain, run query, and see exactly what happened with your system. Here, you will see this is a tracing, and you see chain is a little bit yes, small, but yeah, look at this. This is a chain. So this is tracing. You will see exactly chain is going to, you know, like go to the app B, app A and app B. So it's yeah, from the app A, request an app B and go to the app C. Did the request like a CPU task and IO task. And it will tell you exactly that this is a MySQL. And when you click on this, you will see exactly, yeah, please don't do this. Select star from IO task, and yeah, that's causing you delay about 1 second. And another thing is CPU task. Yeah, I just putting the sleep on here and sleep for the 1 second. So in the overall, you see exactly what happened with your system. Like, okay, this is a 3 second request, and it's stuck on is microservice for 1 second on here. So this is what exactly that you're going to use with the trace. And also you can link with the trace and span and, you know, no, the trace and the log. So yeah, for this LGTMS, can you, you know, doing the data correlation together, you go to the log here and you say exactly at that time, yeah, what happened to the log, what the request, yeah, what's an error going to happen. And also from the log, you can going back to the tracing. Oh, here. Yeah, going to tracing. And yeah, it's going back to the trace. So this is how you're doing, right? It's mean that, yeah, you just, you see, I want to wrapper in this. Yeah, you just have this dashboard to be your war room. You know, yeah, have a big screen on your room and see what happened on your system. And then you see, yeah, this is yeah, it's going to have something with this, and you just go trace, and you go going back and forth between log and trace together. So this is the observability, not monitoring. So yeah, this is the demo I want to show you, and yeah, thank you.
We have some time for the questions. So anyone ask questions?
Yeah.
Okay.
Mm.
Anyone for the question?
Yeah.
Okay. So
Okay,
let's chat. Thank you very much, Jirayut, and yeah, thanks for the cool demo on the Grafana. And for the next talk, oh yeah, thank you. For the next talk, we are still at the Grafana. So coming up from the Grafana team, yeah. So please welcome Joe. Yeah. So maybe let's set up a little bit and in the while, yeah.
Oh, yeah. Thanks. Oh, can you speak
Okay.
right?
Oh yes, yes. No, in. Okay.
I'll be click on the lapel mic. Oh, sure. Oh my God. All right, next up we've got Don't Get Out of Bed for Anything Less Than SLO by Joe Dubal.
Correct.
Working at Grafana Labs. Joe's been building and operating large distributed systems for over 10 years. And yeah, we can, all right, let's take it away, Joe.
Okay. Thank you. Hi, everyone. I'm Joe. I use Grafana all the time, just like our previous speaker.
I'm not actually going to talk about Grafana today, though. I'm going to talk about a DevOps cultural practice, I guess is what I'd say, that I'm very passionate about. I work on a product that helps people use it, but I'm going to talk about the concept in general. Like we said in the intro, I have been building big distributed systems for almost 15 years now. I'm getting on in age. And in that time, I've been following a very sort of DevOps practice in doing that, which means, you know, I'm responsible for the operation and the quality of those systems, not just the quality of the code that goes out, but are they configured correctly? Are they running right? You know, so I've been on call with them. And I love that because it means my team is generally more effective, but I hate that because it means I get paged at 1 in the morning, right? It doesn't happen often, but it happens often enough that it can be really troubling and very stressful. So I want to talk about that a little bit, about what being on call can do to you and for you, and a methodology that can help make that experience better, which is called service level objectives. Talk about how to do those right, and how alerting works in an SLO context, and why it's a nice improvement over what you may be using if you're already doing a sort of DevOps workflow. So burnout is a big problem in the software engineering world. It's something that causes people to quit jobs, which causes software teams to fail, which causes companies to fail. And a lot of us experience it from time to time. In some point in our career, I would bet almost everybody experiences symptoms of burnout. And people are often in some places at a kind of low level state of this all the time. This is a common problem in the field. And I believe that on-call is a big source of this, because things that cause burnout are having unclear expectations of what your job is, not having autonomy or control over what your work is, right? Like being micromanaged, not being able to unplug from work, you're always on the clock, and not being able to actually finish your work. And a bad on-call culture can cause all of these things. Who's responsible when an alert goes off? Can I do anything about it? If I'm paged often in the middle of the night, like an emergency room doctor or a software engineer, can't really unplug from your work, and that leaves you in this sort of high cortisol state of stress. Not being able to ship because you're working on alerts all the time. I realize I have 2 mics. Oh, I do need 2 mics. Never mind. I understand. No, it's fine. I don't mind. And not being able to ship comes out of bad on-call culture too, because you may just be doing alerts all day, every day, turning up the RAM, looking for the network configuration, and that causes burnout too. So when on-call is useful for us, it's because we get the alert to the right person to fix it. The alert is meaningful and actionable, which means you can do something about the source of the alert. And what you're getting paged for is real, right? It's actually something, and it's not just false positive, like we've set a threshold too low and I'm constantly getting alerted when we cross some line. So things that are too frequent don't mean anything. These up our on-call stress and put us in a bad state. So I'm going to talk now about that methodology I mentioned called service level objectives, which is a great way to kind of get out of that state and into a on-call workflow that can be better for you. Because service level objectives help you understand what's the most important thing that users of my system need, right? I'm on call for this. What am I actually expected to provide and at what level? How do I measure that effectively? And then how do I alert on that effectively by understanding the health of the system that I'm responsible for? So SLOs help you prioritize understanding that, alerting on the most important things, and even planning your work based on that state of the system. There's 3 words, but it's really 2 concepts. So service level objectives imply a service level and an objective. The key point here is that service here does not mean microservice or service-oriented architecture or anything like that. We mean service level, like at a nice hotel or a restaurant, they have a high service level. In a software context, service level is what are you providing to your users and how good are you at doing that? So you need to understand what they want out of it and how you measure that that's actually being provided. When I talk to teams or my own team about how to define what that service level is that we're measuring, I like to start with a story.
Can users sign into our app? Turn that into what we think a metric would be, like login requests. Do we have that metric? Let's make sure we can get that metric. And then writing a query that returns a number between 1 and 0, or 100% and 0%. So in this case, we're looking at our login requests succeeding, that status code is not 500 something, and in less than 2 seconds, right? This is a Prometheus histogram metric that we've set with these buckets, divided by the total rate of login requests. So this is giving us how many successful logins as a percentage have we had in the last 5 minutes in that query. That's how we go from like, can users log in, to now we have a number. And this is like a really key step in figuring out an SLO, is figuring out this indicator. It deserves some care and time. Some really common indicators are success rate. In fact, red metrics are a really great starting source for defining SLOs, right? An error rate, a general like sort of request throughput sort of condition. You may have expectations about how much you're able to push through a job, right? If you have a sort of continuous data processing job, you're gonna want something more like successful and throughput compared to just like successful things done. And latency or other sorts of measurements of the statistical shape of your system. Like this, like the 99th percentile latency is below 500 milliseconds, which is telling us the vast majority of users are getting service fast enough, however you define that number of fast enough. The second concept is the objective, which is what level of quality is okay. If you ask your boss, he's going to say 100%. Why can't we just serve 100% of requests correctly, right? Like, hopefully your manager is a little closer to your work and understands that that's an impossibility. But the objective is a target between 0 and 100 over some time period. A month, I like to use 28 days because it eliminates the like, these months have more days than this month kind of problem, and accounts for some sort of weekly variation in requests that you might have. 7 days is another really common kind of target, like we want to hit 99% in the last 7 days measurement. This is why we can't serve 100% of requests, by the way. So this table lists out, you know, if your service is operating, great, 100% all the time, but then you have hard downtime, 0% success for a certain period of time. How long can your system be down and you still hit your objective? Well, over a month, if you're trying to deliver quote unquote 5 nines of reliability, you've got 25 seconds of downtime available to you. So you need to have some really sophisticated automated recovery built into your system if you're going to try to deliver that level of quality. The point here is to, you know, convey that to be realistic about what we can deliver, we should be realistic about what our customer expectations are too. 10 minutes of downtime for an e-commerce application might be really, really bad, but 10 minutes of downtime for an internal developer platform might be okay, right? So there's a sort of, you need to think within your organization, within your team about what's a realistic expectation of quality. When people first start doing this, I usually advise start low, look at where you're at, ratchet it up until you're starting to feel a little bit uncomfortable. Then that's going to motivate you to improve your system, deliver a higher level of quality over time. And another thing you can do, of course, is look back at your measurement over the last few months and find out, you know, what is my sort of average delivery thing here. A key thing is like that top-down objectives don't work for a company or team or whatever to succeed at doing this. Your boss, well, there's 2 parts to this, but internally, if your boss just says everyone's going to do 99.9, some people are going to be fine. Some teams are going to be in a kind of a rut, and what is most common then is that people kind of sweep it over, kind of game the metrics, kind of, you know, just avoid actually doing it. What people need to see is that using this kind of methodology makes my work life better, makes my software quality better, makes my customer experience better. And so you need to start somewhere and ramp up rather than, oh, we're all going to do SLOs and we're all going to set this objective. It really doesn't lead to a successful approach to this. After you get an indicator and an objective, we can start talking about alerting. So we're monitoring based on our user symptoms. And at this point, we're going to start alerting based on when those user needs are not being met. The point to get across here is that alerting is for emergencies. You're gonna wake somebody up at 3 a.m. because things are really broken, not because things might be bad in 4 hours, right? Alerting is not like maintenance. Your system deserves maintenance, but you should be doing that as part of your normal workday, right? You should have dashboards that are measuring resource usage and costs that you're incurring as you run software. But those are things for you to look at during the workday. Things for you to look at 3 a.m. are, we can't sell socks, we can't sell shoes. Not, it's costing us 10% more than our goal to deliver that. So we'll talk a little bit about alerting math to make sure you get alerted at the right time, not too early for little tiny blips, but not too late that you can no longer meet your objectives by repairing your system. To talk about that, I want to talk about our budget. So if we set a 99.9% objective for SLI, then that means 0.1% of our requests over that time period can fail, right? So we can talk about that as a budget, just like a cash budget, and you can burn that budget, just like you can have a burn rate on your cash budget at a company. So we're gonna talk about the error budget burn rate over the next few slides. When you're spending your budget too quickly, you need to pay attention. If you're spending your budget and you'll still be ahead of your objective by the end of your period, there's no reason to be alerted. You do your system maintenance as a normal part of your workday. So in SLO, I like to talk about sort of 4 levels of alerting, which is, it should wake me up because there's extremely high error budget burn happening, hard downtime in the system maybe. There's like, I should look in the morning because maybe in 4 days I'll have used up all of my error budget, right? If things continue like this. There's, we shouldn't alert at all because there's just some little blip in errors maybe that happens. Or there's like, you know, we should do this as part of our normal maintenance of the system because there's some low amount of error burn happening. Translating that into some math, we like to basically measure the burn rate over a few different intervals and then combine these into alerting rules to alert. So measure your SLI over 5 minutes, measure your SLI, sorry, your indicator is what the word I've used before. Measure your indicator over 30 minutes, 2 hours, 6 hours. Then also measured over these longer time periods too. And what we do is combine that short time period and that long time period into a single alerting rule and compare it to this threshold, right? So for very high error rates, we want to measure, is there a very high error rate over the last 5 minutes and over the last hour? What that does is that if there is a super, super high error rate in a short time, we'll get alerted. If there's a somewhat high error rate in the last hour and the last 5 minutes, we'll get alerted. But what we won't get alerted for is one really quick blip that gets above 14.4 but goes back down very quickly. And that's the idea behind all of these, is that we avoid getting an alert for some transient thing that happens and then goes away and now there's nothing to do because the thing has already resolved, which is a terrible thing to see at 3 in the morning. It's a great thing to see and take a look at 10 in the morning when we're on the clock. So that's why we have these different levels of severity. At my work, urgent and high goes straight to my phone, right? Like I get a Slack message and I get an SMS. Moderate goes into a team Slack channel and, you know, we take a look at it if it's happening during the working day or during the next day when we wake up. And low also goes into Slack, but with like no @ mentions or anything like that. We kind of, you know, pick it up as part of a regular sort of grooming of things we've seen come up, right? Like in the weekly team meeting, we'll pop up, how many of these did we get? And do they mean anything, do we think? Should we look into this more or should we, you know, table it and set it aside? So having those different levels of severity for the same measurement can be really effective. And even in a non-SLO context, I think these kind of alerting measurements can be really effective because it's not just like one measurement, set a threshold, get an alert, right? Little blips will cause you problems. So these measuring the same things over multiple time windows and only getting an alert if it shows up in both time windows can be a really effective way to cut down on noise, but still get alerted for serious problems. So even if you're not looking at a service level objectives framework, I would encourage looking at alerting rules and seeing if there's some way of doing something like this, because it can be really helpful for your team's sanity. You can also, once you've got all this kind of stuff set up, look back over time at your alerting rate. This is part of the product that I work on. So like, full disclosure, this is not open source, but this is just a Grafana database, or sorry, a Grafana dashboard. You can download it. But this is in our demo environment. But we have this really noisy, kind of junky front-end system here, right? Where we have a lot of errors happening all the time. We can see the success rate bounces around, right? Somewhere above 97%. But the other thing you can see here is that over the last 7 days, our actual measured indicator is 99.81%. We're still well within our error budget. And you know, all of these little error blips are quite low. So we're actually performing as we expect. And that might look like a really bad chart when you look at it, but people are being served at the level that the team has decided is acceptable. And maybe you want to, you know, ramp that up over time. But so there's no reason to get alerted. We still have 73% of our error budget remaining, you know, towards the end of the window. So the team's in good shape, even if that graph looks kind of bad. And that's kind of a nice thing about this approach, is that you're really getting that final number coming out the end, and not just, oh, at this point in time it looked bad. I think that's a key thing about service level objectives. And this is the kind of, you know, dashboard anybody can put together once you get that indicator measurement. Okay, so to wrap up, talked a little bit about what a bad on-call looks like and why service level objectives is an approach that can help you improve that, how to make service level objectives that make sense, and what that does for your alerting. Thanks very much. We have some time for Q&A if you want. Shy group.
Thank you for the talk. So the question is basically, yeah, it's not just something to call people in the night and be down, but usually it's not enough, right? Let's say there are some situations in some systems and you know that if something's happening in 4 hours, your system will become offline, right? So what about alerting these such cases? Like then system is still available for the users, but you become a timer basically to fix it until to pick up that.
So an example of something like this might be, I don't know if Genny, if you have one in mind. I'm just trying to think of an example of something like that where I might see it.
For example, you have a disk space, and this space is filling up in a rate that in 2 hours the service will just have out of disk space and go down.
Mm-hmm. So I think you can hammer that into an SLO type framework if you wanted to, but you could also write alerting rules that directly that make sense in that sort of approach. But I guess is it something where you have a steady state expectation of the disk space? For example, if you just sort of expect disk usage to be relatively flat, 25% or something, right? Because you're just using it as a write-ahead log or something, right? And you don't want it to go up, then you could write an indicator that says something like, well, we expect the disk usage to basically be flat and below some percentage, right? And as you go up above that, now your indicator starts to look worse and worse, and that can trigger these sort of SLO type alert rules, right? So you could, I like want a worksheet almost, so I could write this out, but you might set something like disk usage below 0.5. So it might be, you know, you'd want something that says like the difference between full and half full or something as your measurement, right? It's always 1 if you're below 50%, and then it gets worse and worse and worse. And then you might set an objective of 99.9, right? So once you go above 50, you're going to start to lose error budget pretty quick, and then you should get paged. You still should get paged at a late time. Sorry? You could, yeah. I mean, I think for the indicator, you can start to get really exotic, right? If you understand your system well, you can write some really complicated indicators as long as they make sense. And you could write it in such a way, right, that if it's hovering at 51%, just because it's above 50, hopefully you don't get alerted for that. But if it's hit 50 and it's heading up towards 60, then probably you should get alerted, right? So having that the slope of that line is sort of incorporated by the distance between, you know, as that number goes down further and further towards 0. So I think you could actually fit discus filling up into that framework if the rate of it filling up starts to look bad enough.
For us, it's a starting considered about SLO. So what do you think is good starting for that?
I think a few really good starting points. Is it a web system, right? If you're serving requests over the web, I think just some really good ones are just like, let's take all of our API endpoints, measure the success rate of hitting those. These are usually like the important things that your end users care about. If you can derive red metrics from that, looking at the error rate, I think is the most straightforward one, or looking at the error rate combined with the latency. I think those are usually really good starting ones. Oh man, yeah. So I started working on SLOs as a product almost 3 years ago now, and we were already using them internally at Grafana, but it's very gratifying to see it expand for sure.
Any more questions? Thank you, Joe, for speaking for SLOs. Hopefully we can implement them in our organization. And now lunch is ready in the main hall area. I'm not sure what lunch is, but there'll be vegetarian options as well. We get questions. We'd like to ask those questions as well. If you want to enjoy your lunch, and we'll see you later.
Yes, and I'll be at the Grafana booth all afternoon. If you have other questions about this, you want to come find me over there. Yep. Thanks. Yeah. Sorry, you guys didn't get the slides.
It's just very messy this year. Yeah, it's like it's submitted.